Good morning and hello everyone. Thank you for joining our talk. So we are going to present on streaming data into Snowflake with StreamNative and Snowpipe Streaming. So we'll walk you through on how we build our real-time data pipeline so that you can apply the same principles and benefit from our learnings that we made here. So quick introduction about myself. I'm Sai Nitish and I've been a senior engineer at Motak for over more than 3 years. And prior to this, I worked at Samsung as a backend engineer. So currently in Motork, I lead the next gen initiatives where we are focusing on building distributed data systems that deliver intelligent real-time insights to our end users and customers.
Yeah, and hello everyone. Thanks for the time. My name is Anirudh. I'm a software engineer at Motork. I'm part of the data analytics and streaming team. Uh, I work on building low latency streaming platforms that derive critical business insights. And I also work on the next gen analytics items such as Snowpipe streaming and data lakehouses, etc. Happy to be here. Thank you.
So Motork in one line is we are a connected vehicle data platform company. Our core mission is to transform raw vehicle data into real-time actionable insights that drive smarter decision for our end users and customers. So we are trusted by majority of the leading OEMs and aftermarket providers. And this gives us direct, secure access to the raw telemetry and diagnostic data straight from the vehicles themselves. So once that data is available and starts flowing into our system, our Motor platform takes over. Our system then standardizes and normalizes this data. And on top of this, we layer advanced analytics and security and scalability to ensure that the system performs reliably at enterprise scale. And from there, we provide a suite of products that deliver insights through our Motor portal, real-time APIs, event streams, and even data warehouses such as Snowflake. And these insights that we provide cover a wide range of use cases across the vehicle cycle, from tracking real-time vehicle status, trip analytics, to advanced metrics such as preventive maintenance and fuel misuse reporting. And our customers, they range from fleets, dealers, and FMCs collect this information, and they collectively operate some of the largest vehicle networks in the US. They use these particular insights to optimize their routing, analyze their driver behaviors for safer and more efficient driving, reducing the fuel cost, preventing accidents through safer analytics, and they proactively use these to address their vehicle maintenance issues. So we are proud to be enabling these the future of this vehicle connected mobility for some of our biggest players in this US automotive industry. So from this, Snowflake plays a pretty important role in our data architecture. Once the data lands in Snowflake, it becomes a single source powering a wide range of use cases, from observability dashboards that monitor our platform health to real-time alerting for operational events. It fuels our data science workflows and machine learning models, thereby enabling like deeper insights on top of them. It also supports something like secure data sharing from Snowflake as well. So overall, to summarize, Snowflake is pretty critical for us. So if you think about our old traditional pipeline, how it used to be is that we used to first get all the data into Snowflake using this particular a batch-based architecture. So we began by first consuming all the data from messaging queues, maybe like event hubs and pulsar topics. And once this data was ingested, we stored it in our blob storage, which in our case was Azure Blob Storage. And from there, we had periodic ETL jobs that ran on a schedule, maybe ranging from a couple of minutes to a few hours, depending on the use cases. These jobs would then pick up this particular stage data and prepare it for loading to Snowflake. So then to move the data into Snowflake, we used a copy into command, which reads from an external stage. So first we created a Snowflake page that pointed to the blob storage location. And then we ran copy into commands to load those particular data directly into our Snowflake tables. So this setup worked reliably for a batch use cases, but over time we began to run into a few limitations. And in the next slide, we can run into a closer look on what these limitations that we faced. So while this architecture worked, it came with three major challenges. The first was latency. Since the ETL jobs ran on a schedule, there was always a delay between the data arriving to being queryable in Snowflake. And this particularly impacted our real-time use cases. And the second was cost. Every batch load triggered intensive warehouse usage in Snowflake, especially during peak times. Over time, this cost started adding up and quickly bloated up the overall Snowflake cost. And the third was maintenance overhead. We had to manage blob storage, monitor the ETL jobs health, and tune each of them very specifically. And this made our overall system harder to scale. So overall, all these limitations made it clear for us that we needed a more responsive, low latency approach, which led us to explore architectures that directly consume from the topics itself. So we set out to redesign our overall pipeline with a few clear goals in mind. The first was latency. We wanted data to be available in near real time. And the second was cost efficiency. This new system had to lower our Snowflake warehouse usage and the overall cost. And the third was scalability. It had to handle the future motor growth. And finally, minimal maintenance, a system that's fully managed and doesn't require ongoing SRE and ops effort. So in short, we are aiming for something that's fast, scalable, cost effective, and maintenance free. So I'll now hand over to Anirudh to go over these details.
Yeah, thanks, Sai. Hello again, everyone. So, having all these goals in mind, we set out to, envision our next-gen architecture. So for that, we obviously needed data in Snowflake and fast and then quickly queryable manner. So that's where we discovered Snowpipe streaming. So Snowpipe streaming, in essence, is a Snowflake native API provided by Snowflake to ingest data into their ecosystem. So this enabled low latency streaming of data directly into rows as opposed to storing them in a remote location and then using a stage or its counterpart Snowpipe. And this was far more quicker and efficient than using Snowflake stages or using Snowpipe to read data. So essentially, you get rid of the files in the middle that help in the transition, thereby making your entire ingestion smoother and faster. And it also does not use warehouses. So when Snowflake, when all your queries did not use warehouses, we were saving a lot on cost. So warehouses, for those of you that don't know, are the compute units for Snowflake. So your compute and you are charged based on that. So yeah, so we were able to ingest data into Snowflake without using warehouses, and that was a deal breaker for us. And yeah, the final icing on the cake is that it also guaranteed data ordering. So for our use case, and I'm sure for many of your use cases, data ordering is a critical component. So we want to deliver data in the same order at which it came in. We don't want to, sort of let the newer messages come first and then the older messages. So yeah, this also guaranteed a data ordering within channels or within partitions, which was a pretty critical component for us. So now the Snowflake part was now figured, but we still needed a way to, have a reliable system that bridged this. So, uh, so to talk about that, we essentially have a streaming ingest API that Snowflake provides, and all our client applications, which will basically stream data onto Snowflake. So internally, Snowflake opens up channels between each of the Kafka topics, and it sort of guarantees ordering and buffering internally. So just to make sure that ordering is maintained. And from there, Snowflake maintains something called micro partitions, which is Snowflake's way of helping us query faster. So this ingestion is not just a very bulk brute force ingestion. It also populates some metadata for micro partitioning for better querying abilities. And then the data resides in your final target tables, which are ACID compliant, and they are immediately queryable. So you use warehouses to query it for your various use cases. So some of the key features that we need to look into Snowflake streaming are your low latency ingestion. It also encrypts data end to end. So from the time data leaves your Kafka to the time data arrives at the Snowflake landing tables, it's end to end encrypted. And this API as well guarantees exactly one semantics. It helps with schema evolution and with less ETL overhead as well. And of course, it's robust and it supports a lot of SDKs as well. So yeah. And now with that being said, we need a platform to enable this. That's where we discovered Kafka Connect. So many of you would already be aware and would have worked with Kafka Connect. But for those of you who haven't, Kafka Connect in simplicity is a framework to connect Kafka with external systems. Like it can either connect Kafka as a source to some external systems, like another Kafka topic or a Pulsar or Snowflake in our use case, something like that. Or at the same time, it can also help bring data to Kafka, like an outbox pattern where you consume the change feed of Postgres or some MongoDB, and you want to stream the data to a topic. So this is a classic Kafka Connect use case as well. So Kafka Connect it has a separate cluster apart from the actual Kafka cluster as well. So in essence, it connects to this cluster to get data from topics and stream into wherever your output is. And Kafka Connect does it with the help of connectors. So it has connectors to do each dedicated task. In our case, the connectors helped in reading data from a Kafka topic and to push them to multiple Snowflake tables. So let's look at this Kafka Connect at a little zoomed in low level. So As you see here, we have multiple data sources and databases that are producing data to Kafka. They are obviously different topics serving different use cases. And from this, we have a Kafka Connect cluster, which has three main components. First is the worker. Worker is the high-level application that orchestrates the entire Kafka Connect model. So whatever operations that you want to do is orchestrated by the worker. And these workers have connectors. So connectors, as specified earlier, are like the individual components that cater to different use cases. Like for example, you want a Snowflake connector or you want a Pulsar connector or whatnot. So these are individual connectors that do your business logic. And these connectors internally spawn tasks. So if you want parallel processing, right? Let's say as your data grows, you want parallel processing to ensure that your latency is still lower and you're not breaching some SLAs. In that case, it helps with parallel processing by just spawning more tasks that help do this quicker. So yeah, this is Kafka Connect. So now we had a streaming ingest API that is provided by Snowflake, and we also had a Kafka connector framework to do this. But to bring it all together, we needed a reliable platform to sort of hold these moving parts together. So that's where StreamNative's Snowflake connectors came in. So what are the StreamNative connectors? They are essentially in one liner would be that they are connectors that are running Kafka Connect underneath, and what do they do? How do they do it? They essentially read data from multiple Kafka topics. I like to emphasize on multiple here because it's not just one topic to one table. You can read data from multiple topics and sync to multiple tables with just one connector. And this is low code, right? Like all you need is a bunch of configs to set things in motion, and this is already well equipped to run high scale data pipelines. Um, and this um, and this connector is very robust as well. So you can use it to cater different use cases. Like for example, in low latency streaming cases where you want data to reach the output tables quickly, in that case you wouldn't buffer much. You would just stream it as and when you get data. On the other hand, there'll be some for example, Lakehouse iceberg use cases where you don't want many small files. So some amount of buffering would be helpful there. So in that case, you can also configure these connectors to buffer data a little bit before pushing it onto the final tables. Um, so yeah, with all this in place, we'd like to show now how our architecture looks right now, our next-gen architecture looks right now. So we got rid of all the moving components, all the unnecessary components, and now in simplicity, it's just these three components. So you have data generation workloads that are pushing data to stream native topics, which are Kafka on Pulsar topics. From there, you have the Snowflake Kafka connector reading from these topics and then pushing to the Snowflake table. So with this, we were able to get rid of all the redundant systems and the remote storages that we were doing earlier, and we were just able to have one streamlined platform to enable all our low latency use cases. So yeah, with that being said, I think we can jump on to a very quick demo as to how we are doing this. So I'll take you to the Stream Native UI right now. So yeah, as you can see here, we want to create a new sync connector. So we want a Snowflake sync connector. This will basically sync data to Snowflake. So this is essentially, yeah, like I mentioned earlier, you just need a bunch of configs to set things in motion. You would give yourself a sync name and a service account that is basically to authorize you and your use case. And you would need a bunch of things like your Snowflake URL and your username and the secret with which you're going to connect to Snowflake. You would also need some more Snowflake data, such as the database where you want this to go to and the schema name, the schema that you want it to go to. And these are all some optional fields that help in better integration. And moving on, this is a key component as well, right? So you want exactly one support to be enabled. So you can change it to enabled if you want such a use case. And as I said earlier, this also caters syncing multiple topics to multiple tables. And so here you can just list out a bunch of topics that you want to sync to. And on a little lower level, you can also have some more configurations. Like for example, you can define which topic has to go to which table, right? Like for example, most of us will have like some genuine naming conventions that we want to be followed across our pipeline. So in that case, you can define which tables you want it to go to. And you have some buffer configs as well. And you have some powerful metadata to power your use case. And one last thing is you can choose what ingestion method you want. It can either be Snowpipe or it can be Snowpipe streaming. For our case, it's going to be Snowpipe streaming. So we already have a connector ready. So as you can see here, we have a Kafka sync connector that we have pre-created for this presentation. So we have this Motok demo connector that's going to read data from a Kafka topic and it's going to push to a Snowflake table. So before that, yeah, if you can see here, this is how the Snowflake UI looks. So the table that we want to push to is we've named it trial table 2. So we'll just query this table for now. And if you query it, yeah, you'll see that we have no data here right now. Now I have a small producer client application that is going to push data to your Kafka topic. So this is again a very vanilla, this is a very simple producer client. It just uses two packages. It has a Kafka, it has a Kafka library, and it has a .env to import all your secrets, your connection strings and whatnot. So here we are just simulating from dummy data with just three variables. We have vehicle number, 25 vehicle, speed, and the distance. And we're trying to push batches of 50 here. So yeah, I'll just run this producer now. So it'll take a couple of seconds to connect and then push data. So yeah, so it has already started pushing. So it's going to be pushing data in multiples of 50. And so also note that the metrics that you're seeing are like asynchronous. So sometimes you might also see more than 200 or more than what you're seeing here. So yeah, as you can see here, we are already pushing data to the topics. So now we can now go to Snowflake and then see how this is behaving. So yeah, before that, I'd also take you to the UI once. So this is the topic that we're pushing to. So demo trial 2. So if you see here, we would have already started pushing data here. Now, if you go to the UI and if you try to query what you're getting, yeah, you can already see that as and when we are syncing data, data is now arriving at the tables. I can also show you how the data looks for sure. So if you look at it here, now the beauty is that the data is parsed. So now you don't need to run your ETL jobs to sort of, get data to your bronze layer and then do all these transformations and get it to your final queryable tables. Of course, this is a very simple example, but we can do other transformations here as well. One more thing I'd like to bring to your attention is this metadata here. So the metadata column here is this essentially provides some powerful metadata for us to analyze the performance of how this table is working. So if you can see here, we have the topic name and we have the create time, the record at which the time at which the record entered the Kafka, and the push time at which the record was supposed to enter Snowflake. So with this, you can also get some, and it also has the offset here to ensure ordering, the partition at which you're pushing to, and whatnot. So yeah, with this, and as you see here, we are pushing data live. So earlier it was 750. So now if we do another count star, it's going to sync data live, right? So as and when you push data, we are getting real-time data here. So this unlocks a lot of critical business use cases that power a lot of our systems. So now I'll quickly jump back onto the presentation. So now I'd like to talk about a couple of key features that helped us power this use case. So we have, as I showed in the demo earlier, we have a bunch of configs that you can fine tune to cater to your streaming use cases. So these are all default configs that came with the StreamNative UI. But yeah, essentially, whichever you have these three things, right? Like essentially the first of this to be met, data is going to be pushed. Like for example, whether you get 10,000 records or you get these many bytes of data or within a flush time of 120 seconds, whichever of these three conditions is first met, the data is going to be pushed to your Snowflake tables. And yeah, this is one more thing exactly once support is also enabled here. So with this, you'll guarantee that whatever data is there in your Kafka, it's going to be pushed exactly once onto your Snowflake tables. So, and one more thing, right? So schema evolution. So, we integrate with multiple OEMs across the industry, and I'm sure a lot of you as well face a lot of evolving data that change over time. So when that happens, we don't want to be in a position where we have to manually go add a new column to the Snowflake table, add some schemas to code, and then to make sure that the schema evaluation is working fine. We want schema evaluation to be on the go. We want it to be practically effortless, and it has to be real time. So with just this one config in the Kafka connector, which is Snowflake enable schematization, we were able to achieve this. So now whether your source starts sending a new column or whether it stops sending one column, all this is just going to be taken care of with your with this one config, and your connector is going to do that for you. Not only is it going to make sure this data is passed properly, it's also going to make sure that a proper column is created with a valid data type and it's going to be pushed accurately. So this sort of unlocked a lot of this unlocked a lot of power for us. At the same time, this also reduced a lot of maintenance and SRE overheads, the one that I spoke about earlier. So Yeah, with that being said, now let's look at some numbers. Let's look at how this entire system helped us. So we have this in production. We can see how this has helped Motork. So we'll be measuring it with some key parameters, that is data latency, infrastructure cost, and scalability. So the current setup that we had right now, the data latency was high, as we spoke about earlier. The data latency was in hours, and the infrastructure was baseline, meaning yeah, if you wanted to scale more, you had to pay more. And scalability was, of course, limited because you can only run ETL jobs as frequent as you can without running into maintenance overheads. Now, let's say we try to scale the current job. In that case, we get lesser frequencies, meaning you'll have more optimized batch sizes. But now your infra cost would be higher because you'll be running the schedules more vigorously and more aggressively. Your infra cost will be higher, and now you'll also see a linear cost increase as well. But here comes the deal breaker, right? With Snowpipe streaming, our data latency was near real time, less than a minute, maybe a couple of seconds, and the infrastructure cost as well got reduced by 60%, and scaling was of course elastic. So if you can see here, we had 60 times faster data availability to query in Snowflake, and some of our customers use Snowflake as well. So this helped them get data at a very at very low latencies. And we had 2.5 times cost savings with the current setup versus 10 times if we plan to scale this current setup out. And obviously, this eliminated all the infrastructure bottlenecks and all the developer efforts needed to maintain this. Um, yeah, so with that, we also needed some way to monitor this. So that's where StreamNative helped us with a Prometheus endpoint. So they exposed a Prometheus endpoint where we got all metrics related to the connector, such as send rates or lag rates. That is how much. By lag rate, I mean how much is the Snowflake push lagging from the Kafka push. And we also have some other metrics such as exception counts and whatnot. We were also able to build some alerting on top of this, such as if the send rate was not as expected, we want to raise an alert, or if there were some error records, we wanted to raise an alert and whatnot. We were also able to build a Grafana dashboard on top of these metrics, and a dashboard look like this. So where you have a real-time dashboards powered with the help of metrics that showed received messages, or how many you've processed, or if there is an exception, or if there are any problems and whatnot. So yeah, with that, I'd like to hand it over to Sai to talk about the future work that we have planned.
Yeah, thanks, Anirudh. So before we wrap up, we first of all want to thank StreamNative for being our partners in this, and we are looking forward to working more with them in these future use cases. So I want to give you a quick glimpse of what we are going to work on in the future, right? So the first is we are planning to integrate Snowpipe streaming with Snowflake managed iceberg tables, where Snowflake themselves are able to take care of the maintenance and compaction of our iceberg tables if you're typically known to the Lakehouse, right? And this will help us bring the low latency streaming data directly into Lakehouse formats. Parallelly, we are also expanding our StreamNative and URSA setup to enable direct real-time ingestion directly into the iceberg format. And then we are planning to use Snowflake to query the iceberg tables directly. So these two are still ongoing efforts, and we're trying to work on them. And to end at this, so at Motak, right, we are currently building the future of intelligence for connected vehicles. Whether it's vehicle telemetry, advanced analytics, or real-time decisioning, we are solving some of the toughest problems in fleet mobility and data infrastructure. And the exciting part is we are just getting started. We are scaling rapidly and taking on key engineering challenges across data streaming, machine learning, distributed data systems, and platform development. So if this sounds exciting to you, yeah, we are hiring. Please scan the QR codes or connect with us on LinkedIn, and let's build the future of connected cars together. Thank you.
All right. Great. Just give the speakers a minute to join us in the main stage. Okay. See, I'll be right back. Okay, perfect.
Yeah,
All right.
hey guys.
Hey guys. Hello. All right.
Hi.
Thanks. First, thanks so much for spending time with us and making yourself available. The session is a great session. It's super insightful. We have some very good questions from the audience, and we are ready to address them. I can read the questions, and then one of you guys or together can elaborate. What do you guys think? Would that work?
Yeah,
Yeah, that works.
Okay, perfect. All right. So first question goes, are you using any schema registry for Kafka messages?
Okay, so for this demo and for our POC purposes, we were not using it because there was some inbuilt schema detection and evaluation that came along with along with the tool, along with the framework. So we sort of leveraged that. But if we needed, sort of stricter adherence, and if we needed to, define some explicit types for the columns and whatnot, then you can go ahead with using a schema registry as well. So the connectors sort of give you an endpoint where you can define your registries, and then your connectors will just pick them up and work from there.
Great, perfect. And I hope that addresses that question from for the person who asked. Alrighty. The next one. Have you considered writing data directly to Iceberg tables?
Yes, this is part of our future roadmap. So we are parallelly experimenting with both URSA and also with Snowpipe Streaming for writing directly into managed Iceberg tables. So Iceberg has its own set of advantages. So it's in the current roadmap as well.
Nice, nice. Perfect. All right. The next question. It looks like the pipeline is pure Kafka based. Did you meet any compatibility issues while building it out on the StreamNative cloud?
Yeah, good question. So the Pulsar topics were exposed with a Kafka head mostly. So the ecosystem came with different connectors, some for Kafka and some for Pulsar. So yeah, the underlying messaging queue doesn't matter as long as you're exposing it to the right head. So yeah, you expose it with 1993, it sort of behaves like a Kafka, right, with a Kafka head. So in that case, the connector was working pretty seamlessly, and yeah, this worked both with Pulsar as well as our the earlier messaging queues that we were in.
All right. The last question we have so far, what is the migration experience from Event Hub to KOP?
So again, so it's a continuation of the previous answer, I think. So for both these use cases, either event hubs or Kafka on Pulsar topics, we essentially exposed both these messaging queues with a Kafka head. So underneath, even though there were different architectures, like the abstraction on top of it was the Kafka cover. So with that, I think the same connectors were able to work seamlessly.
Perfect. Awesome. All right. These are very optional questions, but given that you guys do the demo on the different solutions, I think these are very great questions. And thanks so much for answering them.
Yeah.
Okay.
Thank you.
Great. All right. If there are no more questions, we can give 2 minutes break back to the audience, and we'll see you guys in the future sessions.
Yeah, thanks. Thanks a lot for having us.
Thanks
here.
again, guys. Yeah, have a great day. Okay, bye.
Yeah, you too. Bye-bye.